अस्सलाम वालेकुम स्टूडेंट्स। हमारा आज का टॉपिक है ग्लाइकोलाइसिस। As we know, all living organisms need a continuous supply of energy for carrying out their life processes, and this energy is obtained through cellular respiration. And the mechanism of respiration, the first, the glucose or a hexose sugar gets converted into a 3-carbon compound. The metabolic pathway is called glycolysis, and today we will learn about this glycolysis. This glycolysis term means glycos means sugars, actually hexose sugars. Lysis means splitting, so this is splitting of sugars, and here 6 carbon sugars, whether glucose or fructose, they get splitted into trioses. Trioses are 3 carbon sugars, and these trioses then get converted into pyruvic acid. This is the end product of this metabolic pathway. So overall we see that in glycolysis there is split of hexose sugars, 6 carbon sugars, into trioses, then that is 3 carbon sugars. Then these trioses get converted into pyruvic acid. Since this pathway is common, it is found in both anaerobic and aerobic respiration. So this pathway is also known as common pathway. This common pathway or glycolysis was worked out by 3 renowned German scientists named as Emden, Meyerhoff, and Parnas. For this reason, this glycolysis is often known as EMP pathway. Now, during this EMP pathway or glycolysis, a 6 carbon sugar, that high hexose, is splitted, and the end product of this pathway is the formation of pyruvic acid. Now we will discuss here the different steps of the glycolysis. Now here, the first step in the glycolysis is the phosphorylation. Phosphorylation of hexose sugars. Phosphorylation of hexoses. A hexose sugar, a 6 carbon sugar, whether it may be a glucose or it may be a fructose in case of plants. In case of plants, as we know that the end product of photosynthesis is sucrose, a disaccharide, which gets converted into glucose and fructose to monosaccharides with the help of enzyme invertase. So these monosaccharides readily they can enter into the glycolytic pathway. Now it can be glucose, it can be fructose. Now if it is glucose, this glucose gets changed into glucose 6-phosphate. Here the phosphorus group gets attached to the carbon number 6 of this glucose, and it becomes glucose 6-phosphate. This reaction takes place in the presence of the enzyme hexose kinase, and this reaction needs ATP, so there is consumption of an ATP molecule, so the ATP gets changed into ADP, providing this phosphorus to this glucose, and it becomes glucose 6-phosphate. This reaction also needs magnesium divalent ions. Now if it is fructose, same thing would happen. There is phosphorylation and the same enzyme is involved, and there is consumption of ATP, and which gets converted into ADP, and it becomes fructose 6-phosphate. Now remember, only one thing can happen. Either the pathway would begin from the glucose, or if the fructose enters into the pathway, it would begin from the fructose. Now, If it is taking place, and the first step is the glucose, so entrant is the glucose, it gets converted into glucose 6 phosphate. Now the second step follows, there is isomerization. Isomerization here takes place, that glucose 6 phosphate gets changed into fructose 6 phosphate. Now the enzyme is hexose phosphate isomerase. So in presence of the enzyme hexose phosphate isomerase, glucose 6 phosphate changes to fructose 6 phosphate. Now, if the reaction glycolysis or the pathway is taking place from the fructose changes to fructose 6 phosphate, and there is no need of this isomerization. Now, whether the fructose 6 phosphate is made as this option taking place, or it may take place like this. In both the cases, now this fructose 6 phosphate is further phosphorylated. That means next third step would be again phosphorylation. Here the enzyme is phosphofructokinase. So in presence of phosphofructokinase enzyme, which uses ATP molecule and provides the phosphorus to this fructose 6 phosphate, it gets converted into fructose 1,6 diphosphate. Actually we were saying कि यहाँ पर fructose 6 phosphate का जो phosphorus एक ही था 6th पोजीशन पे, 6 कार्बन नंबर 6 पे, अब कार्बन नंबर 1 पर भी phosphorus आ गया with the help of this phosphofructokinase, और ये बन गया fructose 1,6 diphosphate. Now once again I will recap here that glucose changes to glucose 6 phosphate. This step is known as phosphorylation. Now the glucose 6 phosphate changes to fructose 6 phosphate. This step we will call as isomerization, and then again the phosphorylation, that is fructose 6 phosphate changes to fructose 1,6 diphosphate, and this is another phosphorylation. So phosphorylation, isomerization and phosphorylation. Now there would be the actual step, that is splitting. Splitting of this hexose sugar, that is fructose 1,6 diphosphate, into two trioses in presence of the enzyme aldolase. The two trioses formed are, that is phosphoglyceraldehyde, or we can say glyceraldehyde 3 phosphate, and dihydroxyacetone phosphate. Two types of trioses are formed. These are 3 carbon sugars formed by the split of a 6 carbon sugar. तो यहाँ पर एक्चुअली 6 कार्बन शुगर स्प्लिट होता है 3 कार्बन शुगर के 2 मॉलिक्यूल्स में, एक फॉस्फोग्लिसरल्डिहाइड और दूसरा डाइहाइड्रोक्सीएस्टोन फॉस्फेट. Now this dihydroxyphosphate and the phosphoglyceraldehyde, these are isomers of each other, and here this dihydroxyacetone phosphate, the isomer, changes into phosphoglyceraldehyde by means of the enzyme triose phosphate isomerase. So enzyme triose phosphate isomerase converts dihydroxyacetone phosphate into phosphoglyceraldehyde. So here we can now say that we have 2 molecules of phosphoglyceraldehyde. I will have a recap here that we have started this pathway from the glucose. It can also start from the fructose. So we will take this glucose changes to glucose 6 phosphate in presence of hexose kinase. Glucose 6 phosphate changes to fructose 6 phosphate in presence of the enzyme hexose phosphate isomerase. Now the fructose 6 phosphate changes to fructose 1,6 diphosphate in presence of the phosphofructokinase. Fructose 1,6 diphosphate splits into trioses forming phosphoglyceraldehyde and dihydroxyacetone phosphate in presence of the enzyme aldolase. And now these trioses, they are isomers to each other, and dihydroxyacetone phosphate gets converted to its isomer, that is phosphoglyceraldehyde, with the help of triose phosphate isomerase. And now we will have here two molecules of phosphoglyceraldehyde. Now we have two molecules of phosphoglyceraldehyde, a 3-carbon compound. Now this aldehyde is oxidized to an acid. So the next step is dehydrogenation, and also there takes place the phosphorylation. So the next step would be dehydrogenation and phosphorylation. Here, during this step, phosphoglyceraldehyde or 3-phosphoglyceraldehyde gets converted into 1,3-bisphosphoglyceric acid. Remember, the conversion of an aldehyde into an acid, that is an oxidation. Here, dehydrogenation takes place, and the enzyme is triose phosphate dehydrogenase. Triose phosphate dehydrogenase is the enzyme, and here this dehydrogenase enzyme, as we know, it is linked to the NAD or NADP. Here NAD positive, an oxidized form of this coenzyme. This is the oxidized form of nicotinamide adenine dinucleotide. This gets converted into, or this gets reduced into NADH2, NADH2 or NADH plus H positive. So a reducing substance is here formed, and this reaction also takes up inorganic phosphate in the form of phosphoric acid, and phosphoglyceraldehyde now gets converted into 1,3-bisphosphoglyceric acid in presence of triose phosphate dehydrogenase. Now here we have two molecules of this phosphoglyceraldehyde, so we get here two molecules of this 1,3-bisphosphoglyceric acid, and we can say here two NAD positives are used and two molecules of NADH2 are produced. Now this 1,3-bisphosphoglyceric acid gets converted into 3-phosphoglyceric acid. That means the phosphoglyceric acid, glyceric acid having two phosphate groups, that is 1,3-bisphosphoglyceric acid at position number 1 and position number 3, and this is the glyceric acid having the phosphorus at position number 3. That means position number 1 phosphorus is being removed, and that is used by ADP, and it gets converted into ATP. Because we have two molecules, so the two ADPs would get converted into two ATPs, and there would be formation of two molecules of 3-PGA, that is 3-phosphoglyceric acid. This reaction takes place in the presence of phosphoglyceric kinase. Phosphoglyceric kinase is the enzyme which converts 1,3-bisphosphoglyceric acid into 3-phosphoglyceric acid, and this is the reaction by dephosphorylation takes place. Dephosphorylation means that phosphorus is being removed, and here you can say that this ATP is generated here, and this has been generated directly from the metabolite, so it is also known as substrate level phosphorylation. So this is substrate level phosphorylation here, substrate level phosphorylation. Now this 3-PGA, that is 3-phosphoglyceric acid, gets converted into 2-phosphoglyceric acid. Now as you see here, there is only mutation or change of the phosphorus group from position number 3 to position number 2, and this takes place in the presence of enzyme phosphoglycerate mutase. Phosphoglyceromutase. Mutase is an enzyme which changes the position. Now the position of phosphorus group is changing. 3-phosphoglyceric acid, 2 molecules, will get converted into 2 molecules of 2-phosphoglyceric acid in presence of phosphoglyceromutase. Now these 2 molecules of 2-phosphoglyceric acid get converted into phosphoenol pyravate. Phosphoenol pyravate. Here actually dehydration takes place, and this is done with the help of enzyme enolase. So in presence of enzyme enolase, 2 molecules of 2-PGA, that 2-phosphoglyceric acid, get converted into 2 molecules of phosphoenol pyravate, or simply abbreviated as PEP. So 2-PGA gets converted into PEP. So 2 molecules here and 2 molecules would be formed. Now these 2 molecules of phosphoenol pyravate get converted into 2 molecules of pyruvic acid. This is the end product of this pathway, glycolytic pathway. Here, phosphoenol pyravate gets converted into pyruvic acid in presence of the enzyme pyruvic kinase. Pyruvic kinase is the enzyme which converts phosphoenol pyravate into pyruvic acid. During this reaction, ADP molecule gets converted into ATP. We have 2 molecules, so 2 ATPs would be generated here. So this is again the dephosphorylation, and this again the substrate level phosphorylation. So lastly, at the end product is 2 molecules of a 3-carbon compound, that is pyruvic acid. So I will have a little recap here. We have 2 molecules of phosphoglyceraldehyde. They get converted into 2 molecules of 1,3-bis-phosphoglyceric acid in presence of the enzyme Triose phosphate dehydrogenase. And here, during this reaction, NAD positive, that is the oxidizer form of this NAD positive, nicotinamide adenine dinucleotide, it gets reduced to NADH2, and during this reaction the inorganic phosphate is taken up and phosphoglyceraldehyde gets converted into 1,3-bis-phosphoglyceric acid. Now here 1,3-bis-phosphoglyceric acid gets converted into 3-phosphoglyceric acid in presence of phosphoglyceric kinase. Here 2 ATPs are produced. 3-phosphoglyceric acid gets converted into 2-phosphoglyceric acid in presence of phosphoglyceromutase. Here during this reaction, 2-phosphoglyceric acid gets converted into phosphoenol pyravate in presence of the enolase. Here we know that the reaction, this is a dehydration reaction, so water is being removed here. The phosphoenol pyravate now gets converted into pyruvic acid in presence of pyruvic kinase. Here also 2 ATPs are formed. Now during this pathway, we now say that in the beginning 2 ATP molecules are being consumed, and during this pathway 4 ATP molecules are generated. So if we will subtract the consumption from the formation, there will be net gain of 2 ATPs and 2 molecules of NADH2. Now in an anaerobic organism, with the help of this NADH2, pyruvic acid may either change into an alcohol or it may change into an acid. There is incomplete oxidation, so the net gain would be there only 2 ATPs. But in case of aerobic respiration, these reduced coenzymes are then passed into the mitochondria, where they transfer their electrons and protons and yield A 2 into. Now, in the aerobic respiration, two NADH2 molecules, they are now then passed into the mitochondria, where they generate 2 into 3, that is 6 ATPs. So far in aerobic respiration, the glycolysis would yield 2 plus 6 ATPs, that is 8 ATPs. This was regarding the glycolysis. Hope in this video may benefit you. Remember dear कि आपको जहाँ पर ये समझ नहीं, तो इस वीडियो में अगर आपको कुछ ऐसा है कि समझ नहीं आया है, तो आपको कुछ डाउट है, आप कमेंट सेक्शन में जा सकते हैं और मुझे कमेंट करें। तो उम्मीद है कि आपको ये वीडियो अच्छा लगा होगा। थैंक यू। अल्लाह सन रोज़सन।